Okay, so y equals a b to the x minus h plus k is our general parent function, where a is the vertical stretch, compression, and reflection. H is the horizontal shift. K is the vertical shift. The b is the base. It can be anything. It can be 2 to the x, 3 to the x, e to the x. Whatever that is, that b value is called the base. If that b value, the base, is greater than 1, the function is an exponential growth function. I guess I should have function there. Whoops. How do I undo that? What did I just do? So it's an exponential growth function, and it is increasing from left to right. If b is less than 1, the function is an exponential decay. And is decreasing from left to right. Now, this particular paper doesn't show it, but we typically will say if b is less than 1, but greater than 0, because if it's negative, we see something different. If we've reflected it because it's negative, you'll see something different. The horizontal asymptote is a horizontal line that the curve will get very close to, but will not the asymptote is the value of y. It's the value of y, and it must be written as an equation. Y equals the constant value. So if your asymptote is at -3, you must write y equals -3. You may not just write -3. If you only write -3, it will be wrong and you will not get any partial credit. An asymptote is a line, so you must give the equation as a line. Guys, you're not supposed to be using your computers now, so close them and get these notes so we can move on to the next thing. The y-intercept is the point where the curve crosses what? The y-axis. To find the y-intercept, plug in 0 for x and simplify. Your answer must be written as a point. 0, comma, the number, the value of the y-intercept. If you do not write it as a point, it will be wrong. No partial credit. At the beginning of the year, I let you ease into things and just tell me the value. But when we started second semester, I told you that from now on, x-intercepts and y-intercepts must be written as a point. Okay. The Padlets that for so far that are due.
No, these ones, the exponential ones.
The one that was about the transformations? Yes. Okay, why can I not get this thing to zoom? Because I'm trying to slide it up. So now we're going to look at this. So we're looking at f of x equals 2 to the x. So what is the base? Look at the general form we just looked at. The number that is raised to an exponent, an exponential power, is the base. What's the base? 2. Is this growth or decay?
Growth.
And why?
Because it's going up.
It is going up, but because b is what?
B is 2.
greater than 1.
Yeah.
It is 2. It's greater than 1.
Yeah.
The horizontal asymptote, we have not shifted it up or down, so the horizontal asymptote is y equals 0.
Okay, so if it's like a fraction, right? It's going to decay.
It's going to decay, yes. All right, the y-intercept, until you move an exponential function up or down or left or right, the y-intercept will always be 0, 1. There are 2 critical values in exponential functions. One of them is the y-intercept. The other one is the point 1 comma b, where b is the base. Where b is the base. So I have not shifted it left or right. 2 to the x in this case would be the parent function. So my base is 2. So I know I'm going to have the point 1, 0, 1. And I know I'm going to have the point 1, 2. I know my horizontal asymptote is 0. And then I can draw in the graph. The point so my two critical points here are 0, 1 for the intercept and 1, 2 because my base is 2. Those are my 2 critical points. My domain is all real numbers, negative infinity to positive infinity. My range is 0 to infinity.
That's cool, man.
Must be parentheses because the 0 is not included. So f of x equals 2/3 to the x. What is the base? What's the base? What number is right there? 2/3. The base is 2/3. Is it growth or decay? Decay. Because it's less than 1. Yeah, because it's less than 1. We didn't move it up or down or left or right. My asymptote is still y equals 0. My y-intercept is still 0, 1. That's my critical value. So I know I'm still going to have a point at 0, 1. I'm going to have a point at 1, comma the base, which is going to be hard to do with that being so fat. So 1 2/3 is now my other critical point. So I'm going to go through here, through 1 2/3, and it is going to decrease, approaching the asymptote but never touching or crossing. So we have the point 0, 1, and we have the point 1, 2/3, which is 1, my base. Those are my 2 points.
You can upload this to
Negative infinity to positive infinity. I will upload it later, but I hadn't done it yet. What is the range? What's the lowest value without touching that it can be? It actually goes below 2/3, but it never touches what? 0. So a parentheses and the 0. It can be 0.00000000001. It just can't be 0. So we use the parentheses and the 0, and it goes to infinity. Now, guys, I know this is confusing because the function is decreasing, but domain and range is always written from least to greatest, left to right, right? So if my least value, even though it's going down and approaching 0, my least value is 0, not including 0, so parentheses. My greatest value is positive infinity. So I have to write it that way. Domain and range do not depend on the direction the graph is changing from left to right, only where is it defined. So I think this general function that's printed right here was supposed to be in that box. I don't know why it didn't print in the box, but it didn't. So in this general function for transformation, h is the what? What does h stand for? It moves with x left and right. So it's the horizontal shift. X plus h shifts left. X minus h shifts right. K is the what kind of shift? What does K do? Vertical, because it goes up and down, right? Yeah, this. Plus shifts up, minus shifts down. If A is negative, what does the function do? It reflects across which axis? If A is negative, it reflects across which axis? X-axis. X. There's a hyphen that's printed right there, so I'm going to write axis over here because the hyphen was already printed on your paper. So if A is greater than 1, it represents a vertical what? Stretch. Yes. Very good. If it's between 0 and 1, it represents a vertical shrink. But what do I prefer to call it? A compression. Now, why do I prefer that you call it a compression? You ever put anything in the washing machine and it shrinks?
Yeah.
Does it always shrink the same way?
Yeah.
No. Sometimes it gets skinnier and sometimes it gets shorter. That's not specific enough. If I say it's a vertical compression, that means I am pushing it vertically. I'm pushing it vertically towards the x-axis. So it is going to get shorter. It's also going to get wider, but it's going to get shorter. I'm pushing it towards the x-axis. You have to know the word shrink because you're going to see it in questions from time to time. But the better vocabulary word is compression. It's compressing it vertically. From top and bottom, it is pushing it towards the x-axis vertically. Any questions about this? Okay, f of x. Shh. Stop talking. F of x equals e to the x plus 5. What is a? E is actually the base. What is the number in front of the e? Not a 0, or we wouldn't have an e. 1. So the a value is 1. What is the h value? Is there 1? Is there an x minus h there? No. So the h is 0. What is the k value?
5.
And I just said, what is the base?
E.
Do you know what e is?
No. Actually, no, it's a letter. Yes.
Uh-oh. Oh, well. E is an irrational number. It is approximately 2.71828. Yes, 1828. And then it goes on forever without repeating. It is programmed into the calculator. It's on the button below where the pi is. You'll see it in blue as E. It is a number. It is not a variable. It is an irrational number like pi. And it occurs in nature, studying lots of things about nature. It also occurs in financials when dealing with actuarials and when coming up with a rough estimate of interest when you're dealing with things like that. You know, not when you're signing the contract, but when you're just getting an idea about something. So when you're just having those discussions with your banker or investor or trying to figure it out yourself, it's used there. So it's used a lot in real world applications, and that is approximately what it is. All right, is it growth or decay?
It's growth.
Growth, because
It's over 1.
it's greater than 1. We have not, oh yes we have, we've moved this one up. So our original asymptote was at 0, but now we've moved it up 5. So now our asymptote is at y equals 5. 1, 2, 3, 4, 5. So that's my asymptote, is at y equals 5. So my critical values, the one that was at 0, 1, has been moved up 5. So now I move that up to 6, 1. So this critical value, whoops, I don't want to put that there. This critical value is at 0, 6. It used to be at 0, 1. Now it's at 0, 6. My other, oh, I still put this in the wrong place. Oh, well, let me erase that. Okay. My other value was at 1 comma the base. 2.78 is a little less than 3, so it was at 1 comma 3. Now it's moved up 5, so now it's at 5, 6, 7. Now it's at almost 8. Still going to approach but not touch my asymptote and go this way. So that point is now 0 comma 6. This one is now 1 comma E plus 5. Because it was at E and we moved it up 5. So what is my domain? Still goes left and right forever, correct? You are off task, guys. What is the range? What's the lowest value it can almost be? 5. So this needs to be a parentheses with the 5. So you're going to figure out these always start with the asymptote, but always with a parentheses, because it cannot be that, but it can get very, very, very close. And then from here it goes up to infinity. Oh, we didn't write our asymptote is y equals 5. And our y-intercept now is 0 comma 6. So our transformation, the only one we've made is, it was a vertical shift up 5. Now, I would like to see all of that, but at a very minimum, you have to tell me it's up 5, or moved up 5, or shifted up 5.
Okay.
You can't just tell me it's a vertical shift. You have to tell me how far.
How would you do a horizontal shift on that, on exponents?
You put the minus h up there with the exponent.
Okay.
Okay, so I'm going to leave this next one for you to do. It's also, it's similar to this one. Anybody not have this page? Are you still copying? Is everybody done?
Yeah.
Oh, wait. All right, so now we're going to go over to the back page. I'm going to do the first one, even though it might look to you like the second one is the more complex one. But the first one is reflected. And that makes your graph look and do something that you're not accustomed to. So we're going to do We're going to do the one on the top on this page. So, my A value, what is this out front here? Negative what? 1. What is my H value?
It's negative 1. Oh, wait, which one are you?
Remember that X plus 2 goes left because my formula is really X minus H. So if I have a plus there, that means I have X minus minus. So my H value is really negative 2. And my K value is 7. And my B value here is, what's inside the parentheses? 1/3. Now, the first thing you're going to want to say is this is decay because B is less than 1. The problem is B is negative. So it's going to reflect across the x-axis. So we're going to come back to this, right? It's a decay function, but we're going to be looking at it upside down, so it's going to look like a growth function. We know that it's been moved up, so we know our asymptote is at y equals 7. 2, 3, 4, 5, 6, 7. So that's my asymptote. My y-intercept, we don't exactly know. Okay, so let's talk about this. The parent function starts out with this critical value at 0, 1. The minus sign says we're going to reflect it across the x-axis, so it becomes 0, negative 1. And then we move it up 7. 2, 3, 4, 5, 6, 7. And then we move it left 2. So what I now have is I have a point that's at negative 2, 6, but it is not my y-intercept anymore. Right? Now, a little later on in this unit, you'll learn how to solve this. You set x equal to 0, and you solve it, and you'll find out what the y-intercept is. For now, we're just going to put it on the calculator and look at it. Right. But let's talk about our other critical value first before I put it in the calculator. So this is what was 0, 1 became negative 2, 6. Our other value was 1 comma the base, which is 1/3. It's also moved up. It's also reflected across the x-axis, moved up 7 and left 2. So instead of being at 1, it's now at negative 1, and it's a little above right here. So my function is actually going to go this way. It's going to approach 7 from below. So to find the x-intercept, I need to know what is the y value when x is 0. So I've put the function, oh, you can't see it. I've put the function in the calculator. I have put the function in the calculator like this. I'm going to go to the table and find when x is 0, that is my y-intercept. So 6.8889, but if I want to see what it really looks like, it's 6.88888888 forever with a 9 at the end. So 0, 6.889 is what we'll write for my y-intercept. For my x-intercept, I need to do second trace, find the 0, go left bound, press enter, right bound, Press enter twice. And my y, my x-intercept is when y is 0. If you can see it, is negative 3.771244. Right. So if I go back to my graph, then my y-intercept was at x equals 0, 6.88. Well, really, you could just put the bar on there if you want to.
Wait, could we just round it to 7?
No, because it can never be 7, because that's the asymptote. And then my x-intercept was negative 3.77. So 1, 2, 3, almost. I need to erase part of this. So 1, 2, 3, almost to 4 here. Oh, well, it's not drawn very well. So I took a decay function, which would have been up here, right? It would have been up there. And I reflected it across the line y equals the y-axis. Guys, shh. So my domain is still negative infinity to positive infinity, but my range is now negative infinity to 7, again with the parentheses, because it's not equal. All right, so tell me what transformations occurred. What did the minus do? So we reflected across the x-axis. When you tell me your transformations, you must tell me which axis it's reflected across. You can't just tell me it's reflected. You have to tell me it's reflected across the x-axis. What else happened? What did the x plus 2 do? So it was a horizontal shift, or you could just say shift left. Horizontal shift left 2 units. You must tell me how far. You can just tell me it's shifted left or moved left, but you have to tell me 2 units. What did the plus 7 do? Shifted up. So that was a vertical shift. Up 7 units. You have to tell me how far.
You don't have to put the whole thing, right? You just say it's a vertical shift and it's 7 units.
Yes, you could. Well, no, you have to tell me it's up, because vertical shift could go either way.
Okay.
So if you're going to just give me the minimum, you need to say shift up 7 units, because I know if it's going up and down, it's vertical. But I want to keep emphasizing that to you, because later on when you get to higher level classes, you have to be more specific. So at a minimum, you would have to say reflected across the x-axis, shifted left 2 units, shifted up 7 units. So the other one on this paper I'm leaving for you.